Shravidya. I am JVN Dr.Anamika Ahirwar, Associate Professor in the Department of Science and Technology at Jayoti Vidyapeeth Women's University, Jaipur. Today I am going to take the lecture on the topic Advanced Transaction Processing, second part. In the previous video or session, I talked about the advanced transaction processing. There are many asset properties, asset characteristics, you can say. Now here in this session, I'll discuss about the diagramming and technique Gray and Reuter. You see in this picture that there is abort, begin and commit. Okay, and aborted and this is the committed. So this T is a transaction model. Okay, so if signal enters for the atomic action to perform a safe transition, that means so for this you enter into this either to abort or begin or the commit. Okay, these three conditions are there. So in this in the transaction area, unique persistent transaction identifier, so that for this you can identify that where and how your transaction process is going on. Okay, so in this you see that state indicators of the action's outcome, means your action either should be aborted or committed. Okay, if aborted, then go to the start and then again start the process. If it is committed, then that means your process is completed. Okay, so here you see the active part. Three events can cause an atomic action to change its event. What is that? That is begin, rollback and commit. As I told you in the previous videos, that if rollback means go back to the previous phase, and commit means that means a complete task, or begin means you have to start your process. Okay, so TM is transaction models, and this can define conditions that trigger these events, right? So and the second part is the active. Basically there are two parts, active and passive part. And what is this passive part? Passive means active atomic actions that depend on other transactions that might not be able to make certain state transactions all by themselves. So there must be rules specifying the conditions for performing a signaled state transition. Okay, so look at this example. This is the describing flat transitions. You see here, I have already discussed about this type of diagram in the previous videos. Okay, about the states of like abort, begin, null, commit, rollback, like. Okay, so in this you see there is a system and AC means this A is triggered. Okay, means T transaction is active abort of system TA. This will cause T to roll back or 2. Okay, in this termination 1 means you see here T has committed. So because if C only this is showing me this is in the enable state, so that means your condition is the committed and it will be the final output, you can say. And you see here this pink is the deactivated. Okay, if you are talking about this means termination 2 means T has aborted. Okay, if it starts from this, then see there is no roll of C means there is no final output. Their start is the same and the ending is the same, so means there the condition is aborted. Okay, because there is no source and destination. The source and destination are the same thing. That is A. Next is the flat transactions with safe points. In this transaction safe points, you see this diagram. Here you see that this is the start transaction. There is a safe point 1, safe point 2, safe point 3. In between these safe points, there is a condition of abort, and in between these two, there is a condition of rollback too, right? So rollback means what I said. B means go to the previous one. If there is some kind of error or some type of some bug is there, So the thing is rollback. Okay, so in this relaxing the all or nothing means characteristics of flat transactions. Next is the save point, causes the system to record the current state of processing and returns to handle returns a handle to the application program. Next is the execution between two save points equals to the atomic action, that is SOC. I have already discussed about SOC in the previous video, so just refer to that. In this application program, this can do partial rollback to the specific save point you see here. Okay, so a crash means there is some type of error, so that you can say it is a murder. Okay, means roll back the whole transaction. Now see, this is the save point execution. In this, not show graphically, roll back to a previous save point in the abort of whole transaction. Okay. Now this is a save point 2 taken, means this A is triggered to this, and if this condition there is a termination point, so this is a state where rollback occurs, so go to that previous one. Okay, as I saw in this diagram, this is a condition where rollback go to the previous one. Okay, so here you see in this, and third one is A triggers to this, and this is the condition of rollback, and this is the condition where again rollback occurs. You see here. Okay, this abort and rollback, same here in the form of diagram. Now come to the change transactions. What are these change transactions? This diagram shows that start transactions and commit, and there's various phases. In this rollback you see here, and abort you see here. The commit to ti plus begin to ti plus 1 equals to 1 atomic action, right? So if no other transaction can see or alter the context, data passed from ti to ti plus 1. Next, by commit to ti, the program waives its rights to do a rollback. So by commit to ti, the program can release all the objects that are no longer needed and pass on the processing context to ti plus 1. If at the same time, the whole chain can be seen as one T that keeps all its locks and cursors. So this is basically the chain transactions. Now this is a chain transaction of the normal execution. You see here, this first transaction in the chain A has been started to the second TA, right? And this TA will be triggered by commit to the first TA. This means this is triggered by commit to the first TA. That means this is the deactivated portion in the pink color. So if this is committed to this one and pointing out this, that means this is triggered on B part. Okay, so first TA in this chain has committed, the second TA got started as part of commit of C1. You see here in this A is triggered to this A, and these all are neighbors, so this means this C is committed, and here also this C is committed. So the second TA is structurally dependent on system. Chain transaction restart processing. Okay, in restart processing you see here, this A is triggered to this, and this the final C is triggered to this B part, and what this A again is triggered to B, means parallelly A triggered to A and A triggered to B. So this means if this is triggered to B and this is triggered to A, so this system is a restart, and so what C is doing, C is triggered again to the B, and this C goes to the B. Okay, so this is a chain transaction. Now comes to the chain transactions versus safe points. Firstly, workflow structure. In this, substructure similar to safe points. The second is the commit versus safe points. In this, only rollback to last safe points possible. Safe points in chain transactions other approach. Another is the lock handling. Commit allows to free locks. Safe points have no implication on locks. The next one is the work lost. Means safe points allows for for a more flexible and flexible state restoration. Then if you are talking about the restart handling, means in this reestablishes the state of the most recent commit. So this is basically the difference of the chain transactions and the safe points. Now come to the nested transactions. This nested transactions we will discuss in our next video. Okay, so this is all about today's session, and this session powered by digital version 2.0 Jayoti Vidyapeeth Women's University Jaipur. Hope you are satisfied with my digital session. If you have any query, please mention in comment box. I will resolve it. Thank you.